So again, periodic trends for ionization energy and electronegativity. We're continuing on page 45. Okay? So the first thing for us to talk through is ionization energy. Ionization energy is the energy needed to remove an electron from an element in the gaseous state. Okay, that's the definition of ionization energy. It's going to be measured in kilojoules per mole and reflects how strongly an atom holds on to its electrons. How strongly it holds on to its outermost electrons. So we've got high ionization energy, means that they hold on to those electrons really tightly, and low ionization energy means they only are going to lose one or more electrons because they hold on to them so weakly. Okay? So ionization energies will decrease as you move down a group. As you move down a group, so that's like the lithium and the francium. Why, as you move down a group, do your ionization energies decrease? Right, they get larger energy levels, so their electrons are further away. Okay, it takes less energy to take that electron away. All right. The next part of that we talked about is if we're looking at, say, lithium, it's got 2 energy levels, and neon also has 2 energy levels. Which one has a tighter hold on its electrons? Which one has a tighter hold on the electrons? Neon. It's further over to the right on the periodic table, so it's pulling in really close for its electrons, right? So then this one is going to have a really high ionization energy. The other thing you can look at is I've got 8 valence electrons. Does it want you to take an electron away? No, it's got an octet. So it's going to be really, really unhappy and fight you really hard if you try to take an electron away. That means that you're going to have to exert a lot of energy to try to get that electron out of neon. Okay? So then ionization energies as you go across a period are going to increase. Again, you've got smaller atoms which hold on to the electrons more strongly. Since they hold on more strongly to the electrons, you got to exert more energy to get those electrons away. Okay. This you guys do not have to write down. This is just as kind of a reference so that you guys have seen it before. If you were to write this out as an equation, then you're looking at lithium as a gas, which is where the G is, yields Li plus 1 plus an electron. And that's how you are going to show you've taken one electron away from it. Okay? So if you see an ionization energy equation, this is what that would look like. Okay? And it's got to be measured and studied in the gas phase to be able to get that accurate measurement. Okay? The next trend and the last trend we need to talk about is electronegativity. Electronegativity is how strongly an atom attracts electrons in a chemical bond. How strongly an atom attracts electrons in a chemical bond. And fluorine is going to be the most electronegative element. And here in a moment, I'm going to put the periodic table up, and I want you guys to think through what you think the least electronegative atom would be. Okay. So how strongly an atom attracts electrons in a chemical bond? Okay. Then you've got, which one did we say was the most electronegative? Awesome. So that one's my most electronegative. It pulls electrons the most in a chemical bond. What are we thinking is going to be the least electronegative? So since as you go left, you get weaker nucleus, and as you go down, you get a larger radius, that means that this is the smallest electronegativity. With kind of a caveat, okay? With then clarification we got to make. This is, we said electronegativity is how much they want to attract electrons in what? Say again for me, Ty? Exactly, so a chemical bond. Are there a group that do not want to bond with anything? Right, exactly, those noble gases. So if they don't want to bond with anything, they're going to have an electronegativity of 0. So noble gases have electronegativity of 0. Ian.
Would that tie into why they're not very reactive? Because they have very like no electronegativity.
Yes, so they have no electronegativity because they don't react with anything. Yep, and that ties into, you guys were talking about noble gases. Since fluorine has 7 valence electrons, it really wants to get an extra electron. That's why it pulls electrons so well. Noble gases don't want that because they already have their octet full. Okay? All right, so the definitions we've talked about are atomic radius. You've got the center of the nucleus to the outermost electrons, the distance for that. We've talked about ionization energy, which is the energy needed to remove an electron. And then electronegativity is higher if an atom attracts electrons in a chemical bond. So higher whenever it attracts electrons more closely. Those are the 3 definitions that we have talked about for the 3 different trends.